So, hello everyone. In this class, we are supposed to design an hydroponic system. So, let's look into that. We are using the two sensor. One is the MPC sensor, the other one is the SC22 sensor. MPC sensor is for the temperature, and the SC22 is for the humidity. And we will be using two LEDs for that. And one LED would be dealing with the temperature interrupt, and the other would be dealing with the humidity. So, whenever the temperature is below 20, the LED blinks for the case of temperature, and whenever it's somewhat between 30 to 50, it's like blinks at the frequency of 1, and same goes with the other. Whenever the humidity is quite uh, extreme, the LED stays on, but whenever the humidity is bearable, then the LED blinks, and has different thresholds. So let's look into the header file, how all this implemented, and then we'll be seeing the circuit and looking into how the readings are done. So first, the header file has the basic library that are imported in this, and we have defined the pins. So LED for the temperature pins is at the port 10, P at port A and 10, and then 11 and 2 for the DH sensor, and for the NTC sensor, which actually uses the analog to digital converter to actually convert the temperature, because it doesn't give the temperature degree Celsius. So all those calculations would be done inside the code in order to get that. Then the button, we are using the port 0, which means port A, and 6 pin. For we have two buttons, one would be for the menu, another would be for the selection. Now menu has these choices. First would 0 would be like you want to get the current analysis, what is the current temperature and the humidity. Second option would be what kind of was there a previous alarm. So if you wanted to check the previous alarm, you will be selecting the option 101, and for the option 2 it would be if you wanted the sampling rate to change, so it could be 1 minute, 5 minutes, or 30 minutes, a different frequency. And the second button is to select those options. So first, the time base would, this line says the time base that we are dealing with is on milliseconds. And as I told you earlier, that we need to convert the readings for the NPC sensor to Celsius. So this is the maximum ADC that we can achieve. Then the enum to make the code much more bearable and easier to understand. So we have the sampling rate of 1 minute, 5, and 30 minutes. Alarm at the very beginning would be 0. Warning would be if it's less than 10, or if it is a critical, it would be less than 4. And goes here less than 50 for the humidity, and less than 30 would be LED would be critically low. Then same goes for the different sampling rates. So we need a last temp because we wanted to check was there previous alarm. We need last humidity, last sampling, last everything, because in order to get the current value we have to minus the previous one. So all these variables are assigned over here. And same goes for the global variable, whether the button was pressed, text, menus, and everything, and all those functions that would be using inside the .cpp file. Let's look into the CP file. Now we would be using the serial register inside. So the constant is defined about this much, and we would be for doing the calculation of the NPC sensor. These are the variables that would be using all of them actually to do the calculation, and then the DST22 reading, stating at the very beginning everything needs to be false, then we move turn accordingly as the button is pressed or not. The sampling rate and everything. Most of the code of this file is in basic.cpp, and as you can see, like it calculates in this part of the code. So whenever it gives us the time, it's not in the format of hours, minutes, and seconds. So this line of code converts the time to hours, minutes, and seconds. Then it gets the reading for the sensor and DC sensor. And as I told you earlier, it's not in Celsius, so it gives us the whatever voltage that the temperature is giving to us using the ADC, and then converts it and actually uses the coefficient and the temperature nominal in order to convert that into the Celsius and return it back to. Then what was the condition for the alarm? All these conditions are stated here for the alarm to go on or off. And same goes for the humidity and the temperature over here. Then checking like toggling with the LED part is done here. Then the menu says like what current temperature, all these things will be printed on the serial monitor. Again, the menu selection was done, what kind of selection. So as I told you earlier, 0 would be 1 would be 5 minutes, and 2 would be 30 minutes. And here comes the external interrupt. Now, what is the external interrupt in this case would be the button press. So whether those two buttons were pressed and what button was pressed. Was it the menu button that was pressed or was it the selection button? So that's done using the same SIS and using the external interrupt. And again, the same thing. We need to turn on the peripheral, enabling them. Now, general clock generator is 0 for this case, and turning toggling it. So we are setting it as input. We are taking command from it instead of giving it out to it. That's what it says. Then what kind of pins that we are working with, toggling and enabling those pins using the keymarks, and doing the same with the selection part. Then handling those like with we have the button at 6 and button at 5. So which one of those was selected and what was the last rate? Now the timer counter which we would be dealing with is TC4 because it is for the peripherals, and the other three TCC 0, 1, 2 are for the PWM. So again enabling those and checking it. Synchronization is another thing which is very important because otherwise it won't be working as efficiently. So it is currently the clock cycle runs at 48 megahertz using the prescaler to make it more sensible and readable for us. Again, always checking the synchronization, which is an important part. And just like that, you do the evaluation and it gives you that. And it says like loop, it keeps on giving us back and checking in and all those. The delay is 15 milliseconds. So now let's look into the circuit. So let's look onto the circuit. These two LEDs are the one which would be setting up as the alarm. Others, these are for the other code. And we have the push button right here, one for the menu and one for changing it again and again, selecting it. And here is the Arduino and the ST22. And then the other thing that we have in here is NTC sensors for checking the thermistor of it. Now resetting Arduino board. Just a second. Resetting it and currently checking the temperature. Okay, so currently, as you can see, the temperature is 13, and moreover the humidity is 61. So the threshold for the humidity is below 30, and if it is above 50, it won't glow. You can play around with this if you want your LEDs to set an alarm. And now let's look into the temperature. What is the actual temperature over here? So let's go to weather. Let's see. So it's pretty accurate, to be honest. It's 13, and you can look for other menus if you want. So we have index 1, index 2, index 3. Currently we were at so let's move on. Let's go for the index 1. We don't have any. Index 2. So we can select any sort of frequency if you want. If you want the data at this rate or this rate or this rate, it depends, whatever you wanted to select. So currently we are at index 0. We can have index 1 or 2. Let's go with index 2. So it will select the data, and as we have changed it, you can just again get the data. There you go. Let's refresh the temperature again. Yeah. So that's how you do it. Thanks for watching the video.